Question 97, truck pull. At a county fair truck pull, two pickup trucks are attached to the back end of a monster truck, as illustrated in the figure. One of the pickup truck pulls with a force of 2,000 pounds and the other pulls with a force of 3,000 pounds. There is an angle of 45 degrees between them. With how much force must a monster truck pull in order to remain unmoved? Hint, find the resultant force of the two trucks. That hint there is saying find the resultant vector. Now, there's three ways to go about this. If you need to show your work, this is a good one to go with, because if you remember the law of cosine, okay, up here, the law of cosine, when you're trying to find a length angle or side angle side like we have right now, you can use this formula. A method to get the resultant vector this way is the head and tail method. Now I'm going to draw, from the illustration. So this is one vector, this first vector, and then the second vector. Now I'm just going to change the color on this. Okay, so the two vectors, and here's the 45-degree angle in between them. The head and tail method. Now vectors, they have a magnitude and a direction. So I'm not messing with any of those, and just positioning the second vector to the head of the first vector. Because about the head to tail method is you have your first vector and you connect the second one to the head of the first vector like this. It's also cool that you can just visualize this now, that you can draw, connect the resultant vector right here. It's from the tail of the first one to the head of the second vector. So the resultant vector is in orange here, that you have 2,000 right here, and this is a 3,001. Now from the picture here, you can see that the angle is being formed. This 45-degree angle is forming right here, right? This is where the 45 degree is. I'm moving this back. If we know this is 45 degrees, then right here is just going to be 45 minus 180. That will be 135 degrees. So this right here is 135 degrees. So we have 135 degrees. Now we put that into the equation because now we're trying to find R. And we can say that's even C, length C, and this is angle C, 135 degrees. Now you can just put that into the equation here. A squared, that'll be 2,000 squared plus 3,000 squared minus 2 times 2,000 times 3,000 times cosine theta, which theta is going to be 135 degrees. And when you do that and you square root it, you will get the correct answer, which is 4,635. And that's the first way on doing that. The second way is a lot faster, using this formula right here. Now this is literally just plugging in the numbers they give you from the problem, which is a squared plus b squared, 2,000 squared plus 3,000 squared. Instead of, the only difference here is it's a plus, and the theta is 45 degrees, whatever angle is being formed here between these two vectors. And that will give you the exact same answer. The third way, using the Pythagorean theorem. Now I'm going back to the original, how it started. This is your first vector, and your second vector. It's right here. With the Pythagorean theorem, it's a squared plus b squared equals r squared. That with vectors, they have an x component and a y component. So the let's say Pythagorean is x squared plus y squared. Well, the x squared is, it has to be whatever the x is for this vector plus the x for this vector as well. So you have to find the x on this one, this vector, and the x on this vector. So that's what makes it a little bit more complicated on finding the total x value, because you have to find two values now for these vectors plus y. You have to find the y component of both these vectors. You know, just like Pythagorean theorem, you're going to square these to get r squared. And to make life easier, what you could do is, since these vectors, you can't change the direction or magnitude. So if I were to rotate this y and x axis as so, okay, it's a little weird. So now the x axis is up here, y is over here. Now why I did this is I didn't change anything. All I did was rotate the y and x axis. So now I made this vector here have no vertical component. So there's no vertical component here. So it's easier to deal with. Now the only x and y component is the second vector right here. Now, as we saw from this problem, that the 45-degree angle is formed between these two vectors. So this right here is 45 degrees. And since these are two parallel lines right here with this vector and this one here, that these are, the angle right here will also be 45 degrees. And since this is 45 degrees, you use sine and cosine to find the y and x value of this vector. So it would be 30,000 times sine. It's going to look so bad. I need one of those drawing tablets. That, if you can, this is supposed to say 3,000 times sine 45 degrees. And the x right here, I'll just say it's supposed to be 3,000 times cosine 45 degrees. Now what you would do is, now you found all the components. So you can go back to the Pythagorean theorem and plug these numbers in. So for the x, and the x, you would put those two components. So you would put 2,000, since that's the x component of that vector, the first vector, you put 2,000 plus 3,000, the one I was supposed to write, cosine 45 degrees, as because that's the one right here. I just didn't write it out. Squared plus, since the y is 0 for the first one, and the y here is 3,000 times sine 45 degrees. Oh my god, if I can do that. Now r squared right here, once you add them, you just square this whole thing. And once you do that, then you'll find that r, once again, equals 4,635. Now, there's three ways of doing that truck problem. The first way was head and tail method, which I find the easiest while showing your work. It's just like using the law of cosine. And then the quick way up here is the fastest. And the third way, it's a little bit more steps, but I think that one really explains what's going on with the two vectors, finding the resultant vector. But I hope you enjoyed.